Crouton and Bones House of Math. Names of numbers. Wait, names of hashtags. No, numbers. Names of numbers. Okay, step one. This is concept number 5. No fun, get back to 1. This is, in the trivium, it would be part of grammar. Right? Learning the names of things, words, and so forth. Grammar, you think of grammar as, but the grammar stage, what I'm talking about with lazy English. In the grammar stage, we learn the names of things, but we also learn the syntax around it, which is what you're thinking when it comes to grammar. And in mathematics, it's syntax, and the numbers have names. So this is 1. And look, it's a 1 cube even. It's 1 times 1 times 1, but still just 1. And if I did 1 times 1 times 1 times 1, it'd still just be 1. And I'll show you this in a second, because 1 is kind of fun. All right, so we got our 1 here. There it is. There's a way to describe it using symbols. 10 to the 0 is the same thing as 1. There's a more complicated way of saying 1. And like I said, there's a proof where you can go backwards and they can deduce the fact that it must be 4, 3, 2, 1. I think you can see that on my website elsewhere. But, well, if this is 4, 3, 2, 1, then this must be 0. And any number to the 0 is 1, as it turns out. But that's a whole other thing. We're just naming numbers today. So here is 10 to the 1, right? So what are we basically doing? Extended 3-period lesson. Right, so would you do a 3-period lesson, right? Just maybe take these first 4, and that's it. So you have 1, 10. Oh wait, we'll be in this size. 100, right? And this is a 10. So if this is 10 to the first, then this is 10 square. It sure is. We can get our hands on it, and we can examine it and talk about it. And experience 10 square. That's not just on a page, a 1 with 2 zeros behind it. Look, here it is. And then, we have to change scale because I don't have any big blocks like this on this scale. So we got to change to this scale now where, this is 1. This is 10. Oh, where you go? Right there. Oh. Turn it to the camera. There you go. This is 10. Oh, wait, can I do that? How about that? There you go. Okay. And then 100. And then 1,000. Oh, wait. You guys want to use this? I'm telling you, you're going to have a bad time if you use a cube. What you want to do is make this 10 squared, because it is 100. Oh, look, here it is. So look, we have this symbol and this symbol, but look at we can have this be 100. We could have this be 100. Over here, we could have this be 1,000, and we could have this be 1,000. And you know what we could do that would be fun? And we do this usually in a classroom or the gymnasium, or a yoga studio, depending on the homeschool, where you take this, and then you got to get 10 of these, and make it 10 long. And you'll see that a lot of houses, you can't do it in the living room. Right? I was fortunate enough to have quite a few clients where it was not a problem in their living room. And we didn't have to go to the hallway because they had big houses. But there's a lot of people where getting 10 of these in a row, and there's most classrooms, you can't get 10 of these in a row. Yeah? Or not with ease because there's going to be furniture and all kind of stuff in the way. So anyway, the idea is that we could make this one long and skinny too, and experience it that way. Or we can have it like this, which is a much easier way to do it, where we have hundreds and we stack them on top of each other, if you want to think of it that way. How many hundreds? Well, we need 10 of them. And they can experience it, that, yeah, it's 10 hundreds, and we call 10 hundreds, 10 to the third, 10 cubed, right? Lazy language, people will always call this 10 squared instead of 10 to the second, even when we're using these, because they just get used to saying 10 squared, and clearly this is not a square, but it is the same as one of these. Okay, we're about to launch into much bigger numbers, and because we're going to go all the way to 10 times this. We're going to go 10 times that right there, 10 times the exponent. And that's another thing. Just more language, names of things. This is called the exponent. What's this called? It's base. There's a number written out in long form. 1, 10, 100, 1,000. What's next? The fun one. Oh, wait. Let's do a little more on this. That this is a 10 square by 10. So this shape right here, I'm telling you, much easier than this shape right here. Especially, how are you going to show, if this is going to be your 10 to the third, how are you going to show the next one? Well, you're not, is the answer. Look at me trying to all write neat and everything. 10 to the fourth is 10,000. That's a comma and a period. That's another thing. You can tell what language you're in or where they are by. Sometimes they put dots. But see, then you get, if they put dots out here, you might get confused with the decimal point. So we use a comma. And then we put a decimal point right there, right? Because it would be confusing to do that. Well, what do you mean? And then what do you do with that? So, no, more better we do that. And then we have the period there. And then we're going to have names for all of these guys. Because we're going to have more than 10 and less than 10. Yeah. Close enough. Oh, wait a minute. They both said the same. We're going to go this way. Okay, there we go. Less than 10. More than 10. Where do those symbols come from? There's this thing called a number line. And over there it's less, and over there it's more. So less than, more than. And people have a hard time remembering that. And they talk about alligators and Pac-Man and stuff because math is hard. Okay, so 10,000. Oh, look, let's do something. Let's get rid of these guys so we don't confuse at all. We'll talk about that in a minute. Oh, look, it just so happens it corresponds. 1, 0, 2. It's like we're counting zeros. And a lot of sons and daughters, that's their only experience. And they have no experience of 10 to the fourth. But here we give them an experience, and then we can get them to use their imagination. I'm fumbling around with this thing. It's huge. It's the most fun thing. Right? And what is it? It's 10 square by 10 square, which gives you 10,000. So I know 10 to the fourth is 10,000. And I can compare. Oh, look, there's 1 in 10,000. Can you see that? It would be much better if it was flat. Anyway, how about like that? There's 1. Can I do it? There's manual dexterity. All right, there you go. There's 1 in 10,000. And I can't even show you the whole 10,000. Look at that. That's 1 in 10,000. So now think about 1 in a million. Think about if you're, what is it? The joke in Chinese. If you're a 1 in a million kind of guy, there's 1,000 more just like you. That's how much a billion is. Anyway, all right. So we're here at 10,000. I'm showing 10,000. And how am I showing 10,000? I'm showing 10,000 as 10 square times 10 square. All right, 100 times 100 is 10,000. Oh, see, we get some number sense into these youngins. From an early age, they play with these. And then you can draw pictures of them. So may I draw a picture? And then, here. There's my picture of a 10. Oh, look. There you go. And the ones that always run out, here's my drawing of 100. Okay. Here's my drawing of 1,000. Now, here's the thing. If they just draw, if I want to make it to scale, I'm going to have to make this a lot smaller, aren't I? That's a little better. But if they do that, you might say, oh, is there another way we could draw 100? Because later on, we're just going to flip these and they're going to be X's. Oh, yeah, I could make it like this. There's another way to express that as a drawing. And what are you drawing? You're drawing this. Okay, and you got to take the time with the little ones to talk about it, and play with it, and goof around, just like I am now. Just casually, you're conversating with them about the names of numbers. And what's this one? Oh, man. All right, do I have the one? Of course I do. Let's go with dark blue. Okay, so it would have to be this. If we're drawing to scale here. Oh, let's see, I don't know how long. Let's measure. Oh, bro, look at that. Get in. Okay, we'll call it that. Close enough. And then you can see, and this is the thing that's amazing. The human eye can spot something that's square or that's not square, that's off square. I've known carpenters that can look at a wall and go, that ain't square right there, just looking at it. Anyway, intrinsic to the human, by the way. The whole mathematics, intrinsic to the human. All right, so there's 10 to the fourth. And then, oh, while we're playing, look, I fold it in half here. And while we're playing with this one, we can fool around with that one. Look at, oh, look, there's 10 of these in there. There's going to be 5 there, and if I keep going, there'd be 10 of them. I unfold my 10,000 square. And then we can have more fun experience with this by just, getting out a bunch of hundreds. And going, wow, there's 100 compared to, well, there's 100 compared to 5,000. Open this guy up. And now there's 100 compared to 1,000 or 10,000. Wow. All right, and then I'm going to flip it over on the white side. There's 10 compared to 10,000. All right, and then we should also see that one square, rectangle, square. Oh, but we could turn into a rectangle if we want to, because we can turn any square into a rectangle. And then, oh, look, there it is, rectangle. And we can see the squares in there. Or we could see it piled up as a bunch of these guys 10 times. Or a bunch of these guys, right? 10 times. And then we have 10,000. 100 by 100. 10 square by 10 square. And then, of course, you can flip them over and we can say, oh, look, x to the 0 power. Let's go over here. I'll make it small, not as big. Oh, but I want pens that write darkly. Oh, and not brown. And not purple. Let's go black. All right, I like it. Let's see here. X to the 0, still just 1. We know that, because any number to the 0 power is 1. After that, we don't know. X squared, oops, we'll go x1 first, is, right? We don't know. If it's equal to what? Right? Whatever the number is. X squared. Right? So here, instead of doing that, I'm going to say this is square, rectangle, square, rectangle. Oh, clearly square. So let's make them all small and just use a symbol. Let's see here. Look, this thing got smaller and smaller. Anyway, uh, square, rectangle, square, rectangle, square. So you kind of know what's going to come next. There's going to be a rectangle, right? With 10 of these. And then square. Okay. And I've seen teachers take it to the extreme, and it's awesome, where they get on the gymnasium floor and they get a bunch of 10,000 squares. How many 10,000 squares do you need to make 10 to the fifth? You need a gymnasium. You need like a basketball court. And it's fun. Oops. And all the right, everybody had to make a 10,000 square out of cardboard if they didn't have their own 10,000 square. And they got the dimensions. And in United States, cardboard is easy to come by. I found out in Guatemala, cardboard is not easy to come by. Things we take for granted because our nation is so rich. But that would be 100,000. So you only need, what, 10 of them, right? So you have to get 10 of these guys to get to 100,000. And I should open it up. So now here's what you can do. You can use your imagination and say, you know what? I changed the scale, and now this is 10,000. Right? So what does this make this? This makes this 1,000. And what does this make this? This makes this 100. How tiny my 100 is. You can't even see the 10 or the 1. Oh, derivatives. Anyway, all right. So now I can say if this is 10,000, then this one is 100,000. Right? So I changed my scale. But like I said, if I wanted to use this other scale, and I want to make the next one, which is 10 to the 6th. Am I on? I'm going to slide it out. Wait, now go back. Here I go. Back. And then tilt it this way. Okay. And I can probably cut off the names and numbers part by now. Okay, so now 10 to the 6th. Oh. That means I gotta have 6 zeros. See, and if your only experience is this, your number sense isn't gonna be that great. But if you've been to the gymnasium and everybody bought their 10,000 square, and then you can start seeing, well, let's see here. This is my 10,000 square, and that would make 100,000, and then I need 10 of these to make 1,000,000. So now I've changed my scale. And this is million. Oh, look, what shape is that? And like I said, we can zip any of them out and make them really long, skinny ones if we wanted to, as long as I keep track of my dimensions. But there's 1,000,000, 10 to the 6th. And what comes after 1,000,000? See, we have names for every number. So I'm going to stop this. And you could, and you know what? You could change your scale again. Right? Because if you want to visualize and make bigger numbers, then you just change your scale. So now, what if this teeny little thing right here? Oops, where's that? And I'll let you play. And I'm going to say, this is 1,000,000. This square right here is this one right here, shrunk down again. So what we did is we said, can you use in your imagination? This was my 1,000,000. And what's 1,000,000? It's, what's this dimension? And what's this dimension? Well, think about it. Okay, so over here when it was just 10,000, this was 10 squared by 10 squared. And we added those together and got the 4. Huh. So would this be 10 to the third by 10 to the third to get 10 to the sixth? Why, yes, I think it would be. So in other words, now we're using our imagination, and this distance is 1,000 long. And 1,000 times 1,000 is 1,000,000. Right? 100 times 100 is 10,000. 10,000 10 times is 100,000. 100,000 10 times 10,100,000. If you look at it, 10,100,000 is 1,000,000. What comes next? Right? And like I said, you can keep visualizing this and drawing them and changing the scale smaller and smaller. Right? So that pretty soon, and then what are we going to do? We're going to see that, put it over here, x to the 5th, well, going with our pattern, rectangle, x to the 6th, well, right? Oh, rectangle. Oh, what's x to the 7th going to be? Well, 10 of these. Is there a name for x to the 7th? How about x to the 8th? Well, actually, I should say 10 to the 8th. We have a name for that. Let's see here. And then that'll be the rectangle. And then, oh, 9. That'll be, and then 10. That'll be it. Oh. But see, clearly drawing not to scale, because this would be a huge, huge square. This would be a really long, big rectangle. All right, so we have a name for this, and then let's just play this way. And I could, there's other ways to arrange this where I just 10 to the 7th. Well, that's just 10 million. Right? Okay. So now I'm going to erase all of this. But now, see, you might want to write this part down for sure. Or you could do it over here again, because you can swap these out for 10, right? 10 to the 10th is going to be a square. 10 to the 8th is going to be a square, right? Oh, what do we notice? Odd, even. When I'm talking about the exponent, odd, even. So the even ones are squares, and the odd ones are, right? I'm just pointing that out to you. The child will often point that out to you, for you. Hey, look, there's a pattern there. The even ones are, right? If they don't, point it out. Okay, right now we're playing in the land above 10, more than 10. Eventually we're going to get to the below 10. Maybe I need to make that a whole other video, depending on how much time this takes. But let's erase this. And we're going to go about it a slightly different way. And I'm going to start way over here. Can you still see it? Yes. 1. That's 10 to the 0. 10. 100. 1,000. Now I'm going to do it this way. 10,000. But see, the comma should be right there. 100,000. Right? Because the comma should be right there again. But no, the comma goes back to the right spot. Million. Let's get rid of the commas for the time being, because I know that throws some people off. See, I go back and watch some of my videos, and I can see, one time it was fun, if you get into McRae's page, you'll see where one time we got all kind of algebra on the page, and he's like, I'm so confused. I'm like, you're not confused about anything. What's confusing? But because there was all this algebra and drawings and symbols all over the place, he's like, oh, that looks confusing. But he understood all of it. And then there was another, anyway, I'll make another video about that. Certain things, when you're drawing them and mixing symbols, when they're little, they take it for granted, or they take it literally. So my point being is get rid of those commas. All right, so we've got 1,000,000, and I'll tell you what, I'm going to put all three in at a time. So what do we have here? We're going to go this way. Hundreds, thousands, millions. I just got to 1,000,000,000. But what is it every single time? 1, 10, 100. 1, 10,000, 100,000. 1, 10, 100. 1, 10, so 1, 10, 100. Any kindergartner can understand this. And see, I'm talking from experience. It's not theory. I've been in classrooms. I've been in all manner of classrooms, every grade, K through 12, almost every state, except for Alaska. So I have experience. So don't tell me that you have to wait till they're in fourth grade to start. And right, this should be out of the way, taken for granted. They know it by the time they're 7 or 8, easily. Actually, faster than that. And they should know the names of it because this is vocabulary. And then they've experienced it with manipulatives. And when they see this, they know the word that goes along with it. And they have a vision or an experience or a picture of what this is, instead of just one with some zeros behind it. Because they can really fool around with you and your mind when your only concept is 1 and some zeros, as opposed to understanding. Oh, look, I'll make it white so you can see it. There's 1 out of 1,000. Right? And then you change your scale and make this, oh, there's a game we'll play, where I'm going to change the scale on this. And if it's square, it has to be one of the square ones. So this has to be one of the even ones. And then you compare it to one like this, or one like this, or one like this, and they have to calculate how big. Oh, see, for sure I got to turn it over. If this is, there you go. If this is just a game, just for fun. If this is 1, then this is 10,000. But what if this is 100? Now how much is this? What if this is 10,000? Now how much is this? Right? What if this is million? Now how much is this? Oh, if this is million, how much is this? The green one. If this is million, how much is this? Oh, that's easy, 100 million. Oh, that's easy, 1,000 million, but we have a name for 1,000 million. What's the name for 1,000 million? What's the name for 10,000 million? Okay, I'm going to add 3 more zeros, look. Hundreds now. Thousands. What are these? 1,000. Millions. Billions. Oh, so now I'm over here at 1 trillion. Oh, no, I gotta add 3 more zeros. I'm gonna run out of room with zeros very quickly here. So can you see that it's a whole lot easier to just do, let's see, we're gonna call this 1. And then look, if they're little, we can practice counting. 3, 6, 9, 12, 15. 15 zeros. So this, much easier to just write 10 to the 15. That's why mathematicians are so lazy. We don't want to write all these zeros every time. So we just put 10 to the 15. And then there's going to be some rules of exponents when you multiply and add and subtract, right? Big numbers like this. The notation. And that's all you're doing. And somehow they have managed to make it confusing. And part of the reason why they make it confusing is because you can't visualize past if you use this. Now are you beginning to see why I say if you're wanting to do the mathematics, this is going to be a model that is difficult. And if you get caught up in the model, very difficult to play the game that I was just wanting to play. With this, changing my scale. And what do we have? Hundreds, thousands, hundreds, thousands, millions, billions, trillions, quadrillions. So see, if I knock off 3 zeros here and do this, knocked off 3 zeros, oops, and I get, oh, it's going to be so sloppy, and I don't want to write it again. See how lazy I am? 10, to put it up here, 10 to the 12th is trillion. But see, they get an idea of what happens when you add those 3 zeros. Because a lot of people, it's just 3, it's just the difference between 12 and 15. Or it's just, some more zeros. And they don't see what happens when you start scaling up. There's 1 to 100. Right? There's, do it. If this is 100, how much is this? If this is 100, how much is this? What if this is, again, what if this is million? Then what is this? Okay. So now we're getting big, right? We're going well past 10. Okay? Numbers bigger than 10. We got to go the other way, though. We have names for all those numbers, too. All right. So let's talk about more of them. We have, let's see here. How am I going to do this? Should I go up? Can I make a table like this? I don't know. I guess I would. Can I start down? Yeah, start down. All right, so we're going to go up. There's my point of reference. Oh, I can go way further down than that. How about down here? Okay, we'll say that. That'll be good. All right, so there's 10 to the 0. There's my point of reference. There's 1. Again, what is that 1? Look, I took my 1 and I blew it up. So I make it big so I can play with it. And then I can have my 1 busted into 100, and we'd have hundredths. And then, of course, we'd have tenths. Okay. And we can get them in our hands and hold them, but we're still above 1 at the moment. So using this as 1, okay, I'm going to have to look at notes because, right? Billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, nonillion. That's how far we're going. All right. And then we have names for these. So let's see here. 10 to the first, that's just deca. Right? Like a decameter. Right? As opposed to deci. Right? So, again, grammar, names, learning words and how to pronounce them. Deca should be a D. Deca, as opposed to deci. And deci is when we're less than 10. That would be a tenth. A decimeter, as opposed to a decameter. Names. Now, actually, I'm not even going to do this. We're just going to stay over here. And then I should put the name. This is 1, 10, deca, 100. Oops. And then I just write the right. 100. I'm not even doing it. 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth. You know what's better? 1, 1, 1, 1, 1, 1, 1. 0, 0, 0, 0, 0, 0. Now, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where did we get to? Well, I happen to know that that's going to be trillion. So we're going to start over here. And let's see here. We'll make it 12. And then we'll go up again. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And talk about all the names. See, and if I was able to edit, all of this would just be cut out. All right, 13, 14, 15. These all have names. 17, 18, 19, 20, 21, 22, 23, 24, 25. I managed to get an extra one in there. All right, let's talk about some of the names. A chance to write everything down. Let's see here. At trillion, tera. So when we're talking about terabytes or terahertz, we're talking trillions. And come down to billion, which is way down here. Oh, let's write it. We'll put tera over here. See, because somebody's got to teach them, and nobody does. Now we come down all the way to the 9th. Where are we? Right there. This is gigabytes. Now look at the difference between giga and tera. And then you're going to go up to petabytes. Okay. So let's see here. Down at every 3. Mega. Because what are we counting zeros, right? So megabytes, right? And then we got to come all the way down here to kilobytes. So now we get to experience playing with these guys of kilo, mega, giga, and terabytes. Like when you're playing around with your computers. Gigawatts. What's a gigawatt? What's a kilometer? Right? What's kilohertz? As opposed to megahertz or gigahertz. A difference between a power station that's putting out kilowatts and megawatts or gigawatts. And then measuring all the power in the nations in terawatts. See, I put up a chart recently, and war's over, guys. The Chinese beat us. Why? Because we had satanic pedophiles in charge of our government telling you to save the world by not building power plants. So now they outproduce us. Oh man, I don't even know. Let me see if I can find that chart. By a lot. Like it's ridiculous, and we're not catching up anytime soon unless they let out a couple of pieces of technology. And the only reason why they do it is so that we don't get swallowed up by the Chinese. Because you know how much energy it takes to run AI. So in order to run AI, you need large amounts of power. In order to generate that power, you need power plants. And the Chinese were very clever about telling all the other countries how evil they were by polluting this planet with carbon, which is essential to all life forms, by the way. All life forms on this planet. Well, that's not true. But it's so infinitesimally small, there's an exception. But anyway, the idea is the life forms on this planet are carbon based. The plants, the animals, the fishes. All right, so here it is. Oh, wait. I can even show it to you because I have the power. Oh, I don't know if you can read it though. I don't know if you can see it because of the light on the screen and so on. But oh, maybe I could do this. Oh, I turn them up bright. Does that help or make it worse? I think it makes it worse. Oops, get out of there. Oh yeah, that makes it way worse. All right, so let's try this. Go to auto there. Turn it down. How's that? That's a little better. But all right, let me just tell you what's on there. What it says here is that these guys. Now think about this, and we'll just round it off to 10. They say 10.1, but let's just go. Well, actually, let's do the 10.1. What is that? 10.1 K terawatts. So 10,000 terawatts. Like, that's how much they can currently produce right now. How much United States? Oh, 4.4. Double this, and they still do more. K terawatts. So we're measuring terawatts in thousands. This is a huge divide. And they were very, very clever. And everybody got to feel good about themselves. Because if you ate bugs and we didn't build power plants, that would somehow save the planet. Meantime, the Chinese were building power plants like crazy. And most people, their eyes just roll back over and behind their bin because they can't comprehend this. But we're not going to be able to compete with them when it comes to powering AI. Period. Unless, and this is my hope, they unleash quote unquote free energy. Either using palladium or magnets, which is not such a rare earth. Actually, the stuff that we need to make magnets is found in abundance on the North American continent between United States and Canada. In abundance, we could be building magnetic motors. Further, we could be generating power using water. That's crazy talk. And I'm not talking about like kinetic. I'm talking about actually using hydrogen and then burning that to create heat, to create spin. And then anyway, it's entirely possible. And the mathematics would let you know that this is entirely possible. And that what they tell you about energy is a lie. And what they tell you about pollution is a lie. And it was a lie told by our enemies to make sure this happened. And now some of you might understand what a disadvantage it is to not be able to power AI. They're going to be able to build machines faster, better, quicker, more, just based on the power. And it was 100% you dorks being fooled. And people get upset again by an autistic Scandinavian girl with pigtails. And it was propaganda right down to, just pick up Goebbels' propaganda books and you'll see cute little blonde-haired, ponytailed girls hanging around with, well, see, how long does it take to mention them? right? So they got a cute little blonde ponytailed girl. Dare you? How dare you not keep up with the Chinese? All right, we're not done yet. We got names for these guys because we're only up to Terra over here. So let's see here. Because now we got to go Peta. What's Peta? Peta's over here at 15. Peta. And then what? We got to go to, and that's a quadrillion, by the way, 10 to the 15th. There's quadrillion. See, we have names for all of these. And then let's go up a little further. 10 to the 18 is a quintillion. And a quintillion, 18. Believe it or not, it's exa for 18. I always forget that one. I remember zeta for sextillion. So that's a Z-E-T-T-A. That's 21 zeros. Right? I'll be writing 21 zeros across this board. And some like to do it just for fun. And then we didn't get to 27. I got to keep going. So there's... oh, wait. We got to 24, though. So 24 is yada. Yada know what 24 is. Okay, so yada, and then Roma, and then Keta. And what is that? That's... where are we at? Trillion, quadrillion, quintillion, right? These are all synonyms. These are all names for numbers. Quintillion, exa, and then sextillion, 21 of them, and then octillion. Oh wait, no, septillion. Forgot, right? After 6 comes 7, not 8. Oct is always 8. Octopus, octagon. All right, so let's do. We'll do the last ones. 10. Make it a different color just for fun. 10, 10, 10, 10, 10, 10, 10. Okay, and then what? We are, of course, we are, where are we at? We are 20, well, I'll tell you what, we'll start over here at, we'll call this 26, just because. Oh, shoot, and then I didn't leave the room for, oh, brah. See how you are? Gotta leave room for right stuff, cuz. All right, so 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. And let's go with 25. Oh, I'll tell you what, make this 26. 27 will be there. 28, 29, 30. Although the only problem with that is here you can clearly see the pattern, the 3. Right? There should be 1, 2, 3, and we're going to miss it there. So maybe I tell you what, I'm going to start at 24. And we'll start at Yoda. Yada. So we'll make this 24. There you go. 24, 25, 26, 27, 8, 29, 30. Let's not go to 33. I cracked myself up. All right, so let's see here. So what do we have? We have we got from Yada to Roma, R-O-N-A, or Rona, R-O-N-N-A, is 27. See, these are, you don't even hear these, R-O-N-N-A, except for nerdy math guys. And then you finally get to 30, which is that one. Let's see, I wanted you to see the 3. Well, I should have started at 25. Anyway, because 24 has a name. That's the Yoda. So we'll skip that one. All right, there you go. We're ready to put them there. Oh, you know what? Just leave them. Leave them, cause 24. And put Yoda. That's redundant. Okay, redundancy. Department of Redundancy Department. All right, so now, Quetta. 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 Or Quetta, if you say Cutter instead of Qatar. Anyway, there they all are. Those are the ones past 10. Now you should take a break. Go back and fool around. Play with these guys. Play some games where you talk about, well, okay, if this is one, right? The first one is easy. If this is one, then this is 100. This one's called 1,000. And the big blue one that I'm not going to fumble around with is called 10,000. But now, what if this is 100? What if this is 1,000? Excuse me, not 1,000, 10,000. Because you know what? 1,000 doesn't come in a square. 1,000 comes in rectangles. You can cut the even ones into rectangles, but you can't form the odd ones into squares without a whole lot of algebra. And that was the point of the quadratic, actually, is to take a bunch of stuff and turn it into a square. And we can do that with algebra. But anyway, that's a whole other lesson. And this is talking about the names of numbers. Okay, so we just did the ones past 10. Now guess what? All the ones below 10 also have numbers. And you know what? The numbers below 10 and 1, you know how we're going to... And I didn't even do the whole lesson. I didn't give you all the different... I'll do this. I'll do just a little bit more here. Let's see. For hecto, let's do that over here, because these all have names. We'll put that, get rid of that, and we'll call this hect. Oh, get over there. Hecto, and then over here is deca for the 10. D-E-K-A. There you go. See, you can take a nice screenshot of that, which is why I try to write neatly. Neatness counts. Or I could. There you go. Deca. And then make my 10 nice. Oh my goodness. Let's absorb some toxins through my fingertips. Alright, so. And then we'll go. Boop. There you go. And then let's do the symbols. What do we have for... You should know that kilo is usually not a uppercase, but a lowercase k, stands for kilo. Lowercase h for hecto. And da for deca. D-A. Because see, on the other end we have deci. And we get just the D. Stop it. And if you just have the D, that's a 10. Th. Tenth. All right, so let's see here. Oh, and then we go up. Mega is a capital M for mega. Giga is a capital G and a capital T. So giga and tera. And then, let's see here. Peta is a capital P. Exa is a capital E. Zeta is, of course, a capital Z. Yoda is a capital Y. Is a capital R. And, of course, a capital Q. Standing for it, right? And that's why, well, we'll skip that too. I'm just going to talk about 17 and number thing. What is this? But it's okay. We'll skip all of that. So let's see here. What else? And then I told you the names of everything. I just didn't write them down because I'm lazy. But 1, 10, 100, 1,000, 10,000, million, right? Okay, they all have names. And you get million, billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, and nonillion. Nonillion has 30 zeros behind it. So a 1, and I write it really tiny, and then I have to do those groups of 3 zeros 10 times. And see, and then the little ones can count 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Right? What are they counting? Zeros. That also gives a little bit of number sense. Like, think about how many zeros that is. And then, like I said, once you give them some experience of it with this, and then we're going to go the other way with this, where we're going to talk about tenths and hundreds and thousands and millions and billions and trillions and quadrillions. And I'm going to totally cheat because I'm lazy. And you know what I'm going to do? Oh, I got to erase all this other stuff, but I'm gonna be lazy about it because I am. Let's see here. Let's get rid of all this. And let's get rid of all of this. And we're going to get rid of all of this even. Oops, I should have left the 1. One. And then we're going to go up again. Because I'm lazy. Because actually I should be going the other way when you think about it. But let's just go. And what are we going to do? We're going to go all the way to a. Right now, see, you'll find out about picometers and nanometers and micrometers and femtometers and attometers and zeptometers. All right, and how are we going to do that? We're going to cheat is how we're going to do it. You can put a -1 right there. Negative, 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 negative. What do that mean? That means we're on the other side of the decimal point. Ugh, 0. Oh. What's that? That's a negative sign. That says -21, -22, -23, -24, -25, -24, -25, -26, -27, -28, -29, -30. Look at that ugly symbols right there. Because what that should be is 10 to the -30. What is the name for 10 to the -30? Well, the name for -30 is a kecto, right? It's a nonillionth. And it's a lowercase q. And what's the other one? Down here at 27, that's a ronto. Or I should write them down. I'll write them down. Let's see here. Just because I happen to start back here. And actually, I'm going to do lowercase q. Because the symbol for it is lowercase q. E C T O. You will, I mean, how often are you going to run into this? Not often at all. Ronto. Which is why I'm starting up here and we'll spend more time at the other end. And then this is a septillionth, right? This is an octillionth. This is a septillionth. A yoctosecond. Think about a yoctosecond. Anyway, starts with a Y, lowercase y for the symbol, Y-O-C-T-O, yocto. Let's make it a different color so it's easier on the eyes. There you go, yocto. All right. And then At 20, coming in at 23, we have zepto, which is a sextillionth. Wait, coming in at 24. Yeah, there you go. What am I going to rate? I'm going to rate Yocto. Because I'm 21. Yeah, I'm in the Department of Redundancy Department. And that's a 10. That's a 10. Okay, now I get to the Zepto. And a Zepto is a sextillionth. It's 21 of them. And what is that going to be? Because there's... Okay, anyway. And then here's an interesting one. It's a quintillionth down here at 18. Quintillionth. And that's an atto. A-T-T-O. Now, here is where you're... From here on is where we're going to spend some time talking about these numbers and trying to visualize them and play with these guys. Because what we're going to do now is we're going to take our 100 and we're going to cut it up into 100 different pieces. And then each one of these is now a hundredth. And then guess what? We can take our hundredth and keep cutting it into, right? Okay. And we can use square, rectangle, square, rectangle. But all right, we'll start down here, 1, and then what do we get? We get the guy that can't make a D. Deci. And I don't like this pen. So I will try another pen. How about this pen? All right. So deci, not deca. Deci. That means we're a tenth. 10 to the negative 1. Then a centi. I kind of like it. It's supposed to be an E. C. Centi, like centimeter. That's 1/100th of a meter. Okay, then you cut your centi and you get milli. And that's here, right here. And that's thousand. Milli. Oops, 2 L's. There you go. Milli. That's fun. And then what's next? Micro. That's millionth. Right? We'll skip. Millionth. And I'm ignorant. I just don't know the names. Really? There you go. Millionth. Right? So, and oh, well, that's wrong. It's millionths, but it's not. It's micro. Right? Because this is thousandths, this is millionths, and it's not millions that we're going to put there. It's micro that we're going to put here. Micro. Micrometers. Micrometer. We're down in the micro level. So we're down in the millionths. Oh, and I got to put the symbols. I'll put the symbol somewhere. All right. Let's see here. Micro. Oh, now we finally get to nano. And nano is way up here. At 9 nanometers. How small is that? Pretty darn small. Okay. And then pico is the next one, which is 12. So now we're down at trillionths. Pico. So trillionths, billionths, millionths, thousandths, hundredths, right? Tenths, 1. And then I gotta Oh, and I gotta change this right here because now we're less than 10. Okay. And did I get to the rest? Yes, I did. Okay. Oh no, I didn't because we have now what comes after pico. A lot of people don't know what comes after pico. It's femto. Where are we at? We're down here. Pico at 12 again because I'm in the Department of Redundancy Department. Pico. All right, now over here is femto at 15 of them. What does that mean? That means I have 15 zeros this side of the decimal. All right, and then like I said, next one's atto. And name, don't know. Like I was looking up a couple of them, and at 10, they just say, oh, that's 100 pico meters. But at 100 pico meters, uh, the next is femto. All right, you can talk about, I don't know, picograms. Like we're talking a trillionth of a gram. Um, mercury at a trillionth of a gram. Still toxic to the human. The most toxic substance that's not radioactive known to man. And I have amalgams of it in my mouth. Clearly, somebody wasn't thinking. Or maybe they were. All right, let's start thinking. Nobody likes to do that. Shall I put it up? All right, move back. Everybody's on. Okay. And I guess I'll have to go all the way up here and I'll get rid of this. So now what do? We went from, and we're going to go way over here. This will be 10, right? This would be 11. Like that. Okay. This would be 10. All right. And again, that's our once. So that's a 10. That's a tenth. That's a hundredth. That's a thousandth. And then I need a comma. What? No more blue. Where'd you go? That's a 10,000th. Oops. Right? I'm going to make this a 0 so nobody gets confused that my 1 is actually right here. 1, 10, 100. 1 10,000th. Now I'm just going to go black. Because now with each place, 3, 6, 9, wait, 3, 6, 9. And actually, you know what I got to do if I'm going to fit everybody in there? Because look how many I got to fit in there. I got to get tinier than this, peoples. I'm playing over here at less than 10. Get everything on here? Alright, yeah. Okay, so, we're going to write tiny all the way over at the edge. 1 point. Okay. 1, 2, 3. 1, 2. Oh, see? Wow. Get serious. 2, 3. Okay. We're drawing zeros for days. Okay, where am I at? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So this right here, that. What is that? That's a nonillion. 1 nonillion. We have lots. See, what are we doing? Grammar? What are we doing? Synonyms. So that's a nonillionth. nonillionth, not nonillion, nonillionth with a T, H at the end. 30 freaking zeros, 369, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 3. And you can count them all out and name them, but you're in place 30, and at place 30, you get to Kekto or nonillionth. But see, we're playing in the realm over here, and we have names, and you should be familiar. I'd say probably out to femto now. And this is the other thing. Nanotechnology, compare nanotech to femtotech. Compare nanotech to picotech. There is no picotech. Okay. Do we have particles that small? Turns out we do. And then we start figuring out that there isn't really, this stuff isn't as solid as we thought. It's an illusion. Because things get really weird when you start fooling around in that area that's less than 10. But anyway, we have names for these things. We don't have names for all the experiences and all the stuff that goes on because we want to stay in this world over here where we don't, right? Because when you get small enough, you start getting at the quantum level, right? Down here, what they call quantum, right? This is atomic, and then you have wave. Or you have particle, and you have wave. Right? And then you got to talk about frequency and vibration, and oh man. But let's start off with some vocabulary, so at least we know what we're talking about. And what we're talking about is, oh, here. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, right? And then biddy. Wait a minute, how many? 1, 2, 3, 4, 5, 6, 7. So at 6, we can say, what do we say at 6? 6 places over. Every place has a name. And these only go in groups of 3, the notes that I'm looking at. First it's 1 tenth, to the negative 2 hundredth, to the negative 3 thousandth, to the negative 6 millionth, to the negative 9 billionth. Right? So where are we at billionths? Because see, now we're putting them in groups of 3, but do you see that in this group of 3 we're already at, because that's 1, and we're cutting it up and cutting it up and cutting it up. You gotta use your imagination. First we have this, right? We blow it up to this and we cut it into 100 pieces, and then we take one of these and cut it into 100 pieces. Oh, how do I visualize that? How about like this? There's 100th. So what's one of these? 10 hundredths. What's one of these? Right? You gotta learn the names and play with them. And then you can talk about dimension on this thing. How many pieces are we cutting it into? Alright, so let's see, where was I? Naming everything. Oh, up here. Naming stuff. So, tenths, hundredths, thousandths, millionths. Wait a minute. Tenths, hundredths, thousandths, millionths, billionths, trillionths, quadrillionths. What happens each time? Right, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th place out. Quadrillions, and then quintillions, and then sextillions, and then septillions, and then octillions, and then nonillions. So I don't know what the name is for that thing way over there. Because you see that hundreds and thousands, and then millions, and then how many to get to micro? We need 6 of them. Right? All of these things have names. And then we get out to 12. 3, 6, 9, 12. We're down to pico. And then femto. And then atto at 18. Right? And you're never going to see these guys. Pretty much femto is where you're going to stop. And femto is 10 to the negative 15. What does that negative 15 mean? It means 3, 6, 9, 12, 15. We're femto down here. We're pico over here. And then once we get into the pico, at pico, we are trillions. Right? Synonyms. And femto is quadrillions. And then atto is quintillions. And then zepto is sextillions. And sextillions is zepto. And then all of these have other symbols. Milli. Let's put some other symbols in there. All the synonyms. Okay, let's do that. So let's see here. Just the D for deci, lowercase d. Just the C, lowercase c for centi. Milli, lowercase m. And then we get up to nano. Oh, micro. Upsilon. Let's see. Nano. N. Let's see here. Nano. And then what? Pico. P. Lowercase. And then all the rest of these lowercase. Lowercase f, lowercase a, lowercase z, lowercase, right? The first letter. So all of these just lowercase. And then the other side, when we're above 10, it's uppercase. Okay. You know what? Just so suddenly I'm afraid that I should know this. The Greek alphabet. Just to be sure. I wouldn't want to lead you astray. Oops, what? Search it. Greek alphabet. There you go. And am I correct or no? Let's see, so see? Everything at your fingertips all the time. And wait a minute, what's the name for that symbol? Yeah, oh, mu. Bad, bad, bad. See? Good thing I went check. That's mu right there. Mu. Where's Mui to Moo Cow to celebrate the fact that that's Mu? Here, here, now you remember. Moo! Okay, I think I'm done. Beat this horse. That's kind of important. And then, yeah, and that's another thing. Greek alphabet, right? Knowing the Greek alphabet. Because it's kind of important. It shows up. And being able to look at this and go, oh, that's supposed to be phi. That's supposed to be pi. And see, we get all confused, and which is why we do this a lot of times, because otherwise, Omicron. Anyway, mu. And why mu? Mu for micro. And they use the lowercase m already over here at milli. So then they use the Greek for mu, which is the m. Right? This is the lowercase Greek alphabet m. Mu. And I remember that now. But I've forgotten it. Because long time I never do these lessons. But there it is. Names of numbers. And you could do better than me, where you actually not be lazy. And on a piece of graph paper, you put the slant lines and you write them out. Right? So I know that's a tenth, that's 100, that's 1,000, and the names all the way out. And then knowing the difference between micro, nano, pico, femto, right? Because the next one, right, up is after pico, femto, most people, and then atto, zepto, yodo. And only because I was in a group of people and they didn't know the names. They couldn't remember. And I knew most of them, but see, if you, as my youngest boy will tell you, you might not want to lord this knowledge out over other people. You should know it, and you should teach your sons and daughters. But if you come out and start busting with all of this in a group of people that are talking about, I don't know, nanotech or something like that, they're going to think you're a nerd, which is fine, but just saying. And like I said, he has some great stories when he realizes that, okay, and what are we doing here? In the trivium, where are we? We are in the grammar stage. Now we can start, we got names, we can start multiplying, I don't know, what happens when you multiply 10 to the second, 10 to the negative second by 10 to the negative second? What happens when you multiply 10 to the negative second by, 10 to the third, right? Negative times a positive when they are, when we're talking about exponents, right? There's rules. But first, how about we learn the names of these exponents? Because you're going to get all kinds of fun stuff where they're just fooling around with playing with exponents. But now you know the name. And you know it in the symbols. Because there's that symbol right there. So if you saw a number like 25, right? And I put K here in lowercase, that's 25,000. Right? If I put 25 and I do this, that's 25 micrometers. Generally, we'd be talking about length. But it's 25, and that just means times 10 to the negative sixth. Let's get rid of these guys. Putting some symbols on there to make it look mathy. And if I do 25 m with the lowercase, well then that's 25 millimeters. Or 25 milliliters if we're talking about water or liquids. See, because the numbers have different parts. The how many part and the what kind part. What are we talking about? And we can just start off with even small ones, where we small things like the how many part is 1. The what kind part is, well, on this it's x squared. Turn over. Well, this would be 100. And we could pretend that but we gotta make sure that's clear that we took this and we blew it up, put it in our machine. And I take this, right, when I put it to my machine, and I got one of these. Use your imagination. Okay, so now I've blown it up, and this is hundredth, right? Over here, centi. I've cut my 1 into 100 pieces. And then I gotta do it again to get to milli. Okay. Number sense. And this is fooling around with numbers less than 10. And we have names for everything. The numbers have names. And then we have symbols to go with those names. Okay. CroutonMoonsHouseOfMath.com. 4 more.